Now, in this lecture, we'll find out the value of x using two different methods. In the drawing, we have a quarter circle. EAF is a quarter circle. Inside this quarter circle, we have square ABCD. In addition, we know that this is line segment DE that is equal to 12 units in its length. This is angle GDC is equal to theta. And this is also angle EDC that is also equal to theta. Again, our mission is to find out the length of this line segment GD that is equal to x. Okay, so first of all, we know that we start with the first method. We know that all the angles inside a square are right angles, and therefore this is a right angle. This is also a right angle. This angle equals to 90 degrees. And finally, this angle also equals to 90 degrees in its size. In the next step, we will do a construction. That is to say, we will extend line segment GD and line segment EA by straight line until they touch each other. We will define the touching point of the extended line segment GD and the extended line segment EA as H. We will extend side CD of square ABCD by a straight line. We define this point as point K. We extend inside CD. We created here two vertex angles, and we know that vertex angles are equal to each other. But this angle equals to theta, therefore this angle must be also equal to theta because they are equal to each other. We extended side CD by straight line. Side CD is one side of square ABCD, therefore it is absolutely a straight line. We extended the straight line CD by a straight line, and the result is CK. When you extend a straight line by a straight line, the result must be a straight line. So CK is also a straight line. So if we focus on the lower side of this straight line CK, at point D, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of CK at point D? We have this angle, it is a right angle, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the lower side of the straight line CK at point D to 180 degrees, this missing angle must be equal to 90 degrees in its size. So, what is the size of angle ADH. The size of this missing angle, angle ADH. Angle, it is very easy to see from the drawing that this is angle ADH. It must be equal to the big angle, angle ADK, that is a right angle, minus this angle, that is theta. So in total, and the missing angle ADH must be equal to 90 degrees minus theta. Here we extended EA by straight line. EA, it is a straight line. When you extend a straight line by straight line, the result is a straight line. So EAH is also a straight line. So if you focus on the upper side of the straight line EAH at point A and the upper side of EAH at point A, here the sum of the angles must be equal to 180 degrees according to the same rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of EAH at point A? At the upper side of EAH at point A, we have this angle that is equal to 90 degrees plus this missing angle. In total, the sum of those two angles, they must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the upper side of the straight line E at point A to 180 degrees, this missing angle must be equal to 90 degrees in its size. Likewise, we know that this is one angle of square ABCD, therefore it is equals to 90 degrees. So the big angle, angle CDA, that is equals to 90 degrees minus theta, must be equal to this missing angle. Therefore, the missing angle ADE, this is the missing angle ADE, must be equal to the big angle that is 90 degrees minus theta. So it is equals to 90 degrees minus theta. Okay, so in the next step, we will prove that those two right angles can go into each other. That is to say, we prove that this is the right angle ADH. We prove that it can go into this right angle, triangle ADE. So why those two right angles can go into each other? So we prove that the right triangle ADH can go into this right triangle, triangle ADE. So why those two right triangles can go into each other? First of all, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle ADA. In the right triangle ADH, and it is equals to this angle that is actually angle ADE in the right triangle ADE. Repeat again. Angle HDA in the right triangle ADH equals to angle ADE in the right triangle ADE. They are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, this is side DA, that is a common side that belongs to both triangles. So the side DA equals to itself is a common side that belongs to both triangles. So I write it down. Repeat again. Side DA equals to itself is a common side that belongs to both triangles. And finally, those triangles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle edge AD in the right triangle in the edge, and it is equal to this angle, it is actually angle EAD in the right triangle ADE. So I repeat again. Angle edge AE in the right triangle ADE, angle edge AD in the right triangle ADH equals to angle EAD in the right triangle ADE. They are both equal to 90 degrees, therefore they are equal to each other. So we actually succeeded to prove that the right triangle ADH is congruent. This is the sign of congruent to the right triangle ADE according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove the two angles and the side that is included between the two angles in one triangle are correspondingly equal to two angles and the side that is included between the two angles in a second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. And we proved actually here that those two angles and the side that is included between those two angles in the right, that is actually side DA in the right triangle ADE are correspondingly equal to those two angles, and the side included between those two angles that is the same side DA in the right triangle ADH. Therefore we proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive and conclude that side DE in the right triangle ADE is equal to side DH in the right triangle ADH. So I write it down and conclude that DE equals to DH according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides, that is to say side DE and side DH, must be also equal to each other. But it is given us a question that DE equals to 12. So I can write here that DE equals to 12. And from this equation, 12 equals to DE equals to DH. We will derive that DH also equals to 12 units in its length. So you can write here, original drawing. This is side DH. And it is equal to 12 units in its length. Likewise, according to the same rule that corresponding angles and congruent angles are equal to each other, we derive from the fact that those two right angles can point to each other that side AE in the right angle ADE is equal to side AH in the right angle ADH. So I write it down. Side DE equals to side DH. And again, side DE equals to side DH. But what is the definition of line segment? It is actually side AE. This is side AE. And conclude that side AE equals to side AH. Repeat again. Side AE equals to side AH. But what is the definition of side AE? Side AE, it is very easy to see. We know that side AE is the radius of this quarter circle. So we define the radius of this quarter circle as R, therefore A equals to R. So I can write here that A equals to R according to our definition. And for this equation, R equals to A equals to DH, we derive the DH also equals to R. So I can write here that it is actually side AH. Repeat again. We will derive from the fact that those two right angles can point to each other that side AE equals to side AH. Again, side AE equals to side AH. But according to our definition, AE is the radius of the quarter circle that is equal to R, and from this equation R equals to AE equals to AH, we will derive that R equals to AH. R equals to AH here. AH equals to R. In the next step, we join points G and E together by a straight line. We join points G and E, we create a triangle HGE. And we join points A and G together by a straight line. Here we join points G and E together by a straight line. Here we join points G and A together by a straight line. In relation to triangle HGE, point A is the circumcenter. Point A is the circumcenter of triangle HGE. So I write it down here. Point A is defined as the circumcenter of triangle HGE. That is to say, the distance of point A from the three vertices of triangle HGE is equal. For example, the distance of point A from the vertex edge of triangle HGE is R. Likewise, the distance of point A from the vertex G of triangle HGE. What is the distance AG? What is the length of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that is equal to R according to our definition. And therefore, the distance from point A from point G is R, exactly like the distance of point H from point A, and finally the distance of point A from the vertex E of triangle AGE is also R, because AE equals to R. And for that reason, point A is defined as the circumcenter of triangle HGE. Okay, that is from one side. But from the other side, if we complete this quarter circle to a circle, we get a circle that its center here is here at point A, and the radius is also the same radius R. Repeat again, if we complete this quarter circle to a circle, we get a circle that its center is located here at point A, and its radius is also R. Because the radius of the quarter circle is R, and therefore the radius of the circle must be also equal to R. So we have here two circles. One circle that is completed, that will be created by completing this quarter circle to a circle with radius R and the center A. And the second circle is the circle that blocks triangle HGE. We know that the circle that blocks triangle HGE must pass through its three vertices, that are H, G, and E. So, the radius of the circle that blocks triangle HGE starts from point A, because point A is the center of the circle that blocks triangle HGE, and ends at point E. Why? Because the circle that blocks triangle HGE must pass through point E. So the radius starts from point A because it is the center, and ends at point E because it must pass through point E. This is exactly the definition of a radius. So AE is the radius of the circle that blocks triangle HGE, and AE equals to R. And therefore, the circle that blocks triangle HGE has radius R, and its center is located at point A. But the circle that will be created by completing this quarter circle to a circle, its center is also at point A, and its radius is also R. So we have two circles with the same radii and the same center. Two circles with the same radii and the same center is not they are not two circles, but one circle. It is the same circle. Because if we have two circles with the same center and the same radii, it is one circle. And therefore, we can conclude from it that the circle that will be created by completing this quarter circle to a circle is also the same circle that blocks triangle HGE. And therefore, the circle that will be created by completing this quarter circle to a circle must pass through its three vertices that are H, G, and E, and especially it must pass from point H. That is one vertex of triangle HGE. So, I repeat again, the circle that will be created by completing this quarter circle to a circle must pass from point H, because it is also the same circle that blocks triangle HGE. Okay, now I will complete this quarter circle to a circle, and we know that the circle that will be created here must pass through point H. Okay. Repeat again, this is the circle that is created by completing this quarter circle to a circle. and it is also the same circle that blocks triangle HGE, and therefore it must pass through point H. So what is the, so I write it down here, that point A is the center of the circle that blocks triangle HGE, and as I already explained, the circle that blocks triangle HGE is also the same circle that will be created by completing this quarter circle to a circle. So I completed this quarter circle to a circle. It must pass through point H, because this circle must also block triangle HGE. So what is the definition of line segment HAE? First of all, we know that angle HAE equals to 180 degrees in its size. And we know that any angle that is equals to 180 degrees in its size it is defined as a straight line. So HAE is a straight line. But HAE is a straight line that touches the circle at 2 points, point H and point E. And therefore it is defined as a chord. Any straight line that touches the circle at 2 points is defined as a chord. But HAE is a chord. HAE is a chord that passes from point A, and therefore, and we know that point A is the center of the circle, and we know that any chord that passes through the center of the circle is defined as the diameter of the circle. So HAE is the diameter of the circle. If HAE is the diameter of the circle, HE is also the diameter of the circle. So write it down. HE is the diameter of the circle. So here we have peripheral angle HGE. This is peripheral angle HGE. This peripheral angle HGE is subtended on HE, that is the diameter of the circle. And you know that any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. Therefore, this is peripheral angle HGE, that it must be equal to 90 degrees in its size according to the rule that I mentioned. So this is the right angle. So in the next step, we'll focus on quadrilateral ADGE. Again, we'll focus on this quadrilateral ADGE. This is the green quadrilateral ADGE. Inside this green quadrilateral, we have those two opposite angles. Each of them is a right angle. And the sum of two right angles is of course 180 degrees. And we know that any quadrilateral, that the sum of its two opposite angles is equal to 180 degrees, it is a cyclic quadrilateral. Therefore, the green quadrilateral is a cyclic quadrilateral. That is to say, we can block this quadrilateral by a circle. So I will block this quadrilateral, ADGE, the green quadrilateral, by a circle, because we know that the sum of its two angles is equal to 180 degrees. Therefore, it is a cyclic quadrilateral. The red circle blocks the green quadrilateral ADGE. Why? Because it passes through its four vertices A, D, G, and E. Now we can implement here rule 12. I'll repeat quickly on rule 12. Rule 12 is true in any circle. So in any circle, if we have here, this is called BA, and the extended chord BA touches the common external point P. Likewise, we have chord DC, and the extended chord DC touches the same common external point P. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement this rule 12 in our drawing. Why? Because in our drawing, if you focus on the red circle, if you focus on this red circle, inside this red circle, we have chord GD, and the extended chord GD touches this common extra point H. Likewise, we have inside the red circle chord EA, and the extended chord EA touches the same common extra point H. Therefore, all the requirements of rule 12 are satisfied, and for that reason, we can implement here on the red circle rule 12. And according to rule 12, the following equation will be true. HD times HG equals to HA times HG. Again, HD times HG equals to HA times HE. So I write it down. So if we focus on the red circle, according to rule 12, the following equation is true. HD times HG must be equal to HA times HE. Repeat again. According to rule 12, if you focus on the red circle, the following equation is true. HD times HG equals to HA times HE. HD is 12 times HG. What is the length of side HG? Side HG equals to HD plus DG. That is to say, HG equals to HD, that is 12, plus DH, that is X. So in total, HG equals to 12 plus X. And it must be equal to edge A. Edge A is R, it is the radius of the circle that is R according to our definition, times edge E. Edge E, we already found out that edge E is the diameter of the circle, therefore it is equal to 2R. So actually, according to equation 1 and rule 12, we found out that 12 times 12 plus x equals to r times 2r. Here we will divide this equation 1 by 2. And we get that according to equation 1, here we have 12 over 2 is 6, so in total this expression will be equal to 6 times 12 plus x, and it is equals to, here we have r times 2r is 2r squared, and 2r squared over 2 is r squared. So in conclusion, we found out that according to equation 1, 6 times 12 plus x equals to r squared. Here we will divide this equation 1 by 6, and finally we get that according to equation 1, 12 plus x equals to r squared over 6. So here we will subtract 12 from this equation 1, and we get finally that according to equation 1, x equals to r squared over 6 minus 12. Okay, then again, according to equation 1, x equals to r squared over 6 minus 12. X is the variable that you are looking for in this question. I remind you that x is the length of this line segment GD. So in the next step we will implement the Pythagoras theorem on this right triangle ADE. So I copy triangle ADE in a new page and we will implement on it the Pythagoras theorem. But before that, we will define one side of square ABCD as y, and therefore all the four sides of this square ABCD will be equal to y. That is to say, side AB equals to y, according to our definition, side BC equals to y, side DC equals to y, and finally side AD also equals to y. Now we copy this triangle AD in a new page, and we will implement the Pythagoras theorem on this right green triangle AD. Here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Side AD equals to y according to our definition. It is given as the question that the hypotenuse DE of the right triangle AD equals to 12 units in its length. And we already found out that AE equals to R. It is the radius of the circle, it is equal to R. So this is the right triangle AD that I covered from the original domain. According to the Pythagoras theorem, in this right triangle ADE, DE squared equals to AD squared plus AE squared. DE is 12, therefore DE squared is 12 squared, that is 144. And this equals to AD squared. AD is y, therefore AD squared is y squared plus AE squared. AE is r, therefore AE squared is r squared. So in conclusion, we found out that according to equation 2, y squared plus r squared equals to 144. In the next step, we will join points A and C together by a straight line. By joining points A and C, we created the right triangle ABC. So we'll copy this right triangle ABC in a new page and we will implement on it the Pythagoras theorem. But before that, what is the definition of the hypotenuse AC? The hypotenuse AC starts from the center of the circle, that is to say from point A, and ends at point C, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of the circle that is equal to R according to our definition. Now we'll copy this triangle ABC in a new page and we'll implement on it the Pythagoras theorem. Here by PT is abbreviation for Pythagoras theorem. The hypotenuse AC equals to R, AB equals to Y according to our definition. This is one side of square ABCD, and BC also equals to Y. So this is the right triangle ABC that I copied from the original drawing according to the Pythagoras theorem. In this right triangle ABC, AC squared equals to AB squared plus BC squared. AC, the hypotenuse AC equals to R, therefore AC squared is R squared, and it is equals to AB squared. AB is Y, therefore AB squared is Y squared, plus BC squared. BC is also Y, therefore BC squared is Y squared. So according to equation 3, we have found out that R squared equals to Y squared plus Y squared, that is 2Y squared. This is according to equation 3, while according to equation 2, we have already found out that Y squared plus R squared equals to 144. Here we will divide this equation 3 by 2, and we get that according to equation 3, Y squared equals to R squared over 2. Now we can substitute Y squared in this equation 2 by R squared over 2 from equation 3. We'll do it now, and we get that according to equation 2, Y squared is R squared over 2 plus R squared, that is equal to 144. So here we will multiply R squared by 2 and then we will divide it by 2 in order to overcome a factor with R squared over 2. And we will get, in total, in the numerator we will have R squared plus 2R squared, because we multiplied R squared by 2, divided by 2. And it is equal to 144. So according to this equation 2, we have R squared plus 2R squared, that is 3R squared, over 2, that is equal to 144. Here we multiply this equation 2 by 2, and we get that according to equation 2, 3R squared equals to 2 times 144 is 288. So according to equation 2, 3R squared equals to 288. Here we divide this equation 2 by 3. And finally we get that according to equation 2, R squared equals to 288 over 3 is 96. This is according to equation 2. So according to equation 2, r squared equals to 96. Well, according to equation 1, we have already found out that x equals to r squared over 6 minus 12. So x equals to, now we can substitute r squared in this equation, equation 1 by 96 from equation 2. We'll do it now, and we get that according to equation 1, x equals to r squared is 96, so in total this expression equals to 96 over 6 minus 12. 96 over 6 is 16, and 16 minus 12 is 4. In conclusion, we actually found out that x equals to 4 units. X is the length of this line segment GD. So GD that is equals to x is equals to 4 units in its length. And again, this line segment GD that is equal to x is equals to 4 units in its length. So we finished with the first method. In the next step, I will present to you how to find out the length of this line segment GD that is equal to x according to the second method. So we know that all the angles inside square ABCD are right angles, so here this angle equals to 90 degrees in its size. This angle also equals to 90 degrees in its size. This angle equals to 90 degrees in its size. And finally, this angle is also equals to 90 degrees in its size. In addition, we know that in square ABCD, the opposite sides are parallel to each other. It is true in any square, especially it's true in square ABCD. In square ABCD, the opposite sides are parallel to each other. That is to say, side DC of square ABCD is parallel to the opposite side, side AB. Because again, in square ABCD, side DC is parallel to the opposite side, side AB. But here, side AB is part of the straight line AE. Again, side AB is part of the straight line AE. So we know that part of the straight line AE is parallel to DC, therefore the straight line AE itself must be also parallel to DC. Very simple. So AE must be also parallel to DC. Repeat again. Side AE must be also parallel to side DC. Those two angles, they are defined as alternating angles, and they are located between the parallel side DC and AE, and therefore they are equal to each other. Again, those two angles are equal to each other according to the rule that the alternating angles between parallel lines are equal to each other. Okay, but this angle equals to theta, therefore this angle must be also equal to theta because those two angles are equal to each other. Okay. In the next step, we will do a construction. That is to say, from point G, we will go perpendicular on AB. Again, from point G, we will go perpendicular on AB. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point G and AB as N. Likewise, we will define the intersection point between the perpendicular GN inside DC of the square as M. By doing this construction, we created quadrilateral DMAN or MDAN. Inside this quadrilateral MDAN, we have 1, 2, 3 right angles, and therefore this fourth angle must be also equal to 90 degrees in its size, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside this quadrilateral DMAN, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral DMAN with 4 right angles as a rectangle. So I write it down here. This quadrilateral is a rectangle because it has 4 right angles. Okay. GN is perpendicular, so GN is a perpendicular, it is absolutely a straight line. So we focus on the left side of the straight line GN here at point M. So which angles we have? And we know that at the left side of the straight line GN at point M, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of the straight line GN at point M? We have this angle that is a right angle plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. So this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles on the left side of the straight line GN at point M to 180 degrees, this missing angle must be equal to 90 degrees in its size. So in the next step, I will copy this small right triangle GDM in a new page, and we will analyze this right small triangle GDM. So actually, this is the right triangle GDM that I copied from the original drawing. According to what is given as the question, the hypotenuse GD equals to x. X is the variable that we are looking for. It is the length of the hypotenuse. And this is angle theta, also according to what is given as the question. And this angle equals to 90 degrees according to the rule that I mentioned. So in this right triangle GDM, it is very easy to see that cosine theta equals to dm over gd. So cosine theta equals to dm is the missing side, so we leave it as it is, over gd. Gd equals to x according to what is given as the question. So in conclusion, we found out that according to equation 1, cosine theta equals to dm over x. Here we will multiply this equation 1 by x, And finally, we get that according to equation 1, dm equals to x times cosine theta. In the next step, I'll copy this right triangle ADE in a new page, and we'll analyze this right triangle ADE. But before that, we will define one side of this square ABCD as y, and therefore all of its four sides must be also equal to y, of course. So AD equals to y, AD equals to y according to our definition. AN also equals, AB also equals to y. Side AB of square ABCD equals to y. CB equals to y. And finally, side DC of square ABCD equals to y. So now I'll copy this right triangle ADE in a new page, and we will analyze it. What is the definition of side AE? Actually, side AE starts from the center of the quarter circle, that is to say from point A, and ends here at point E. This is exactly the definition of a radius. So AE equals to the radius of the quarter circle. We'll define the radius of the quarter circle as R, therefore AE equals to R. AD equals to y according to our definition, and it is given as the question that D equals to 12 units in its length. So actually this is the right triangle ADE, that I copied from the original drawing. Repeat again. This is right triangle ADE, that I copied from the original drawing. So here the most important thing is that this is angle theta. This is angle theta. So in this right triangle ADE, it is very easy to see that cosine theta equals to AE over DE. So cosine theta equals to AE, that is R, over DE, that is 12. So in total, actually, found out actually that cosine theta equals to R over 12. This is according to equation 2. While according to equation 1, we have already found out that dm equals to x times cosine theta. So now we can substitute cosine theta, this cosine theta from this equation 1, by R over 12 from this equation 2. We will do it now, and we get that according to equation 1, dm equals to x and cosine theta according to equation 2 is r over 12. So in total we shall find out that dm equals to xr over 12. Again, dm equals to xr over 12. Here, this is sine dm that is equals to xr over 12. But we have already found out that quadrilateral DMAN is a rectangle here. What's it here? That it is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMAN, side DM must be equal to the opposite side AN. But DM equals to XR over 12, therefore AN must be also equal to XR over 12. Likewise, according to the same rule, in the same rectangle DMAN, side DA must be equal to the opposite side MN. Again, side DA must be equal to the opposite side MN. But DA equals to Y, therefore MN must be also equal to Y. In the next step, we'll return to our right triangle GDM and we'll continue to analyze it. So I copy this right triangle GDM again in a new page and we'll continue to analyze it. So this is the right triangle GDM. This is a copy from the original drawing. In this right triangle GDM, it is very easy to see that sinus theta is equal to GM over GD. Again, sinus theta in this right triangle DGM is equals to GM over GD. So GM is the missing side, so we leave it as it is. So it is GM over GD. GD is X, so we substitute GD by X. So actually, in conclusion, according to equation 1, we actually found out that sinus theta equals to GM over X. Okay, according to equation 1, sinus theta equals to GM over X. Here we multiply this equation 1 by X. And finally we get that according to equation 1, GM equals to X times sinus theta. In the next step, I will copy the right triangle ADE in this new page and we will continue to analyze it. So actually, this is the right triangle ADE. Let's copy it from the original drawing. This right triangle ADE is very easy to see that sinus theta equals to AD over DE. So sinus theta equals to AD is the missing side, so we leave it as it is. This is AD over DE. D is 12. So according to equation 2, we actually found out that sinus theta equals to AD over 12. This is according to equation 2, while according to equation 1, we already found out that GM equals to x times sinus theta. So now we can substitute sinus theta in this equation 1 by AD over 12. But AD is y, okay, AD is y. So here, sinus theta equals to AD over 12, AD is y, so it is y over 12. So actually, sinus theta equals to y over 12. According to equation 2, sinus theta equals to y over 12. This is according to equation 2, while according to equation 1, dm equals to x times sinus theta. Now we can substitute sinus theta in this equation 1 by y over 12 from this equation 2. We'll do it now, and we get that according to equation 1, gm equals to x times sinus theta. Sinus theta according to equation 2 is y over 12. So in total, we actually found out that gm equals to xy over 12. Okay, gm equals to xy over 12. So this is side gm. This is equal to xy over 12. In the next step, we will join points A and G together by a straight line. So what is the definition of line segment AG? Line segment AG starts from the center of the quarter circle, that is to say from this point A, and ends at point G, that is a point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of the quarter circle that is equal to R according to our definition. Okay, so in the next step, we'll copy this right triangle AGN in the new page, and we will implement on this right triangle AGN the Pythagoras theorem. So what is the length of side GN in this right triangle GN? From the drawing it is very easy to see that GN equals to GM plus MN. So GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. So I'll write it down. So actually, this is right triangle AGN is the common original domain. Here by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle AGN, the hypotenuse is AG, therefore the square of the hypotenuse is AG squared, and it must be equal to AN squared plus GN squared. Okay, I'll repeat again. According to the Pythagoras theorem, in the right triangle AGN, AG squared equals to AN squared plus AG squared. Okay, so AG is R, therefore AG squared is R squared, and it is equals to AN squared. AN is XR over 12, therefore AN squared is XR over 12 squared. XR over 12 squared equals to X squared times R squared over 12 squared, that is 144, plus AN squared. AN is Y plus XY over 12, therefore AN squared is Y plus XY over 12 squared. So here we take y as a common factor from this expression, and we will get that r squared equals to x squared times r squared over 144, plus here we take y as a common factor from this expression. So y is a common factor. So what is left from y after we took from it y as a common factor? What is left is actually 1, plus we have here what is left from xy over 12 after we took from it y as a common factor. What is left is actually x over 12 squared. Now we will open one pair of brackets of this expression, and you get that according to equation 1, r squared equals to x squared times r squared over 144, plus, so we open one pair of brackets here, and we get here it is y squared, and also here it will be y 1 plus x over 12 squared. So here we will multiply, in this expression we multiply 1 by 12 and then we divide it by 12 in order to overcome factor with x over 12. We'll do it now and we'll get that according to equation 1, r squared equals to x squared times r squared over 144 plus y squared. So here multiply 1 by 12, so in total the numerator will have 12 plus x divided by 12 squared. Repeat again. According to equation 1, we actually found out that squared equals to x squared times r squared over 144 plus y squared times 12 plus x over 12 squared. So this expression according to the algebraic identity that a over b squared equals to a squared over b squared. So according to this algebraic identity, we get that this expression equal 12 plus x over 12 squared will be equal to 12 plus x squared over 12 squared, that is 144. Repeat again, that 12 plus x over 12 squared, according to this algebraic identity, will be equal to 12 plus x squared over 144, and we have to multiply it by y squared plus x squared times r squared over 144, and it is equals to r squared. This is according to equation 1. In the next step, we will join points A and C together by a straight line. By joining points A and C, we actually created the right triangle ABC. So I'll copy this right triangle ABC in a new page, and we will implement on this right triangle ABC the Pythagoras theorem. But what is the definition of the hypotenuse AC? The hypotenuse AC starts from point A, that is the center of the quarter circle, and ends at point C, that is the point on the quarter circle itself. Therefore, AC is the radius of the quarter circle, that is equal to R. Now I'll copy this right triangle ABC in a new page, and we'll implement on it the Pythagoras theorem. Here by PT is abbreviation for Pythagoras theorem. Side AB equals to y, and side BC also equals to y. Both those sides are the sides of the square, and one side of square ABCD equals to y, according to our definition. So actually, this is the right triangle ABC that I copied from the original drawing. This right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So write it down. AC squared equals to AB squared plus BC squared. So AC equals to R, therefore AC squared is R squared, and it is equals to AB squared. AB is y, therefore AB squared is y squared, plus BC squared. BC is also y, therefore BC squared is y squared. So in conclusion, according to equation 2, we actually found out that R squared equals to y squared plus y squared, that is 2y squared. Repeat again, according to equation 2, we found out that r squared equals to y squared. So actually, according to equation 1, we have already found out that r squared equals to x squared times r squared over 144 plus y squared times 12 plus x squared over 144 repeat again, according to equation 1 we actually found out that r squared equals to x squared times r squared over 144 plus y squared times 12 plus x squared over 144. This is according to equation 2, while according to equation, this is according to equation 1, while according to equation 2, we have already found out that r squared equals to 2y squared so now we can substitute r squared in this equation 1 by 2y squared from equation 2. We will do it now and we get that according to equation 1 we have here r squared. R squared is 2y squared according to equation 2, so it is 2y squared. That's equals to x squared, and r squared is 2y squared over 144 plus y squared times 12 plus x squared over 144. So here we divide this equation 1 by y squared, and we get that according to equation 1 2y squared over y squared is 2, and it is equals to here y squared will get cancelled and we're left only with 2x squared over 144 plus here y squared also will get cancelled and we're left only with 12 plus x squared over 144. So here we will multiply this equation 1 by 144, and we get that according to equation 1 2 times 144 is 288, that equals to 2x squared plus, so 144 we get cancelled and we left only with 2x squared plus here also 144 in the denominator we get cancelled and we left only with 12 plus x squared. Here we open the brackets of this expression and you get that according to equation 1 288 equals to 2x squared plus we have 12 plus x squared. 12 plus x squared equals to 12 squared, that is 144, plus x squared, plus 2 times 12 times x is 24x. So, according to equation 1, we actually found out that 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144 equals to 288. Here we subtract 288 from this equation 1, and finally we get that according to equation 1, in this side of the equation we have 3x squared plus 24x, and here we have 144 minus 288 is minus 144. This equals to 0. So we found out that according to equation 1, 3x squared plus 24x minus 144 equals to 0. We will divide this quadratic equation by 3, and finally we found out that according to equation 1, 3x squared over 3 is x squared. 24x over 3 is 8x. And finally, minus 144 over 3 is minus 48. This equals to 0. So, actually, this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So now we put the values of a, b, and c that we found for our specific quadratic equation, this quadratic equation, in this general formula for x, in order to find out the values of x in our specific quadratic equation. I remind you that x in our specific quadratic equation is the length of line 7 GD. Again, we'll put the values of a, b, c here, those values inside the general formula in order to find out the value or the values of x for our specific quadratic equation. We'll do it now, and we get that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64. Minus 4 times a is 1, so minus 4 times 1 is minus 4. Times c is minus 48, and minus 4 times minus 48 is plus 192. So inside the root we have 64 plus 192 divided by 2a. a is 1, therefore 2a is 2 times 1, that is 2. So in conclusion, actually found out that x equals to minus 8 plus minus, and inside the root we have 64 plus 192, that is 256 divided by 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 divided by 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x, I actually found out that x equals to minus 12, but x can never be equal to minus 12 because of the fact that x is the length of line 7 GD. So x as a length, it must be a positive number. It can never be equal to any negative number, so we'll cancel this solution, and we'll take into account only the positive solution for x. And the positive solution for x is x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So actually found out that according to the second method, x equals to 4 units. Again, x is the length of this line 7 GD, so the length of line 7 GD is equal to x is equal to 4 units, also according to the second method. So in the next step, I'll summarize the lecture. We start with the first method, of course. In this lecture, we found out the length of this line 7 GD is equal to x. So, in the drawing we have a quarter circle. FAE is a quarter circle. Inside this quarter circle we have square ABCD. In addition, we know that this is line segment DE, this equals to 12 units in itself. This is angle theta, this is actually angle GDC. This is also angle theta, this is actually angle EDC. Again, our mission is to find out the length of this line segment GD is equal to x. We have to find out the value of x. Okay, so in the first method, here, first of all, we know that ABCD is a square, and we know that all those four angles inside this square ABCD are right angles. And so here, this angle equals to 90 degrees in its size. It is one angle of square ABCD. So the big angle ADC equals to 90 degrees in its size. This angle equals to theta. Therefore, the missing angle here, that is angle ADC, must be equal to the big angle ADC minus theta. Again, angle ADC equals to 90 degrees minus theta. Okay, and then we did a construction. That is to say, we extended line segment GD and line segment EA by straight line until they touch each other. They touch each other here at point H. We define their touching point as point H. And then we extended side CD of square ABCD by straight line. We define this point as K. So those two angles, angle KDH and angle CDE, angle GDC, angle GDC and angle KDH, both those two angles, they are defined as vertex angles, and we know that vertex angles are equal to each other. But this angle equals to theta, therefore this angle must be also equal to theta because of the fact that those two angles are equal to each other. And then we know that according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. We know that CD is a straight line. When you extend a straight line by straight line, the result is a straight line. So CK is also a straight line. So if you focus on the lower side of this straight line CK at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of CK at point D? We have this angle that is a right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees. So therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the lower side of CK at point D to 180 degrees, this missing angle, that is to say the missing angle KDE, the missing angle KDA, this missing angle must be equal to 90 degrees in its size. So the big angle KDA equals to 90 degrees. So 90 degrees minus this angle theta must be equal to this missing angle. So this missing angle HDA must be equal to 90 degrees minus theta. And here we extended the straight line EA by straight line, and the result is EH. Therefore, when you extend the straight line by straight line, the result is a straight line. So EH must be also a straight line. EH is a straight line. So if we focus on the upper side of the straight line EH at point A, Here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. Then the sum of the angles from one side of a certain is equal to 180 degrees. So which angles we have at the upper side of E edge at point A? We have this angle that is equal to 90 degrees plus the missing angle. In total the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the upper side of the straight line E edge at point A to 180 degrees, this missing angle must be equal to 90 degrees in its size. That is to say, the missing angle DA edge must be equal to 90 degrees in its size. In the next step, we proved that those two right angles can go into each other. That is to say that the right angle AD edge, this is the right angle AD edge, that is can go into this right angle, triangle ADE. So why those two right angles can go into each other? First of all, those two angles are both equal to 90 degrees one theta, therefore they are equal to each other. In addition, this is side DA, that is a common side that belongs to both triangles, so we can write now that side DA equals to itself as a common side that belongs to both triangles, and finally those two angles are both equal to 90 degrees, therefore they are equal to each other. So we actually proved that those two right angles can go into each other according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove the two angles and the side that is included between the two angles in one triangle are correspondingly equal to two angles and the side that included between the two angles in the second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. And we proved that those two angles in the side that included between those two angles, that is side DA in the right triangle ADE, are correspondingly equal to those two angles and the side that included between those two angles, that is the same side DA in the right triangle ADH. Therefore, we actually proved that those two right angles can go into each other according to angle side angle rule. And from the fact that those two right angles can go into each other, we derive that side DE in the right triangle ADE is equal to side DH in the right triangle ADH. Repeat again, we conclude that DE equals to DH. According to the rule, the corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say side DE and side DH, must be also equal to each other. So DE equals to DH, but D equals to 12 units according to what is given us in the question. And so we can write here that D equals to 12, and from this equation 12 equals to D equals to DH, we will derive that DH also equals to 12 units in itself. Here DH equals to 12 units in itself. Likewise, because of the fact that those two right angles can go into each other, we will derive that side AE equals to side AH. Side AE equals to side AH according to the same rule that the corresponding angles in congruent triangles are equal to each other. But side AE, this is side AE, is the radius of the quarter circle, so we define the radius of this quarter circle as R. Therefore, here we can write that A equals to R, and from this equation R equals to AE equals to AH, we will derive that AH also equals to R. Here AH equals to R. In the next step, we join points G and E together by straight line. By joining points G and G, by joining points G and E, we created the right triangle GEH. And then we join points G and A together by straight line. Actually, point A is defined, but what is the definition of line segment AG? Line segment AG starts from the center of the quarter circle and ends at, that is to say from point A, this point, and ends at this point G, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AG is the radius of the quarter circle that is equal to R according to our definition. So in relation to triangle HGE, point A is defined as the circumcenter of triangle HGE. Again, point A is defined as the circumcenter of this triangle HGE. That is to say, the distance of this point A from the three vertices of triangle HGE is equal. For example, the distance of point A from the vertex edge is R. Likewise, the distance of point A from the vertex edge is also r, and finally the distance of this point A from the vertex G of triangle HGE is also r. Therefore, point A is defined as the circumcenter of this triangle HGE, and also because of the fact that point A is the circumcenter of this triangle HGE, point A is also the center of the circle that blocks triangle HGE. Again, point A is the center of the circle that blocks triangle HGE. We know that any circle that blocks triangle HGE must pass with three vertices that are H, G, and E. Okay, so the circle that blocks triangle HGE must pass from point E, and its center is located here at point A. So what is the radius of the circle that blocks triangle HGE? The radius starts from the center, that is point A, and ends at point E, that is a point on the circle that blocks triangle HGE. This is exactly the definition of a radius. So AE is the radius of the circle that blocks triangle HGE, and therefore it is equals to R. So the radius that blocks triangle HGE equals to R, and its center is here at point A. And it passes through its three vertices that are H, G, and E from one side, but from the other side, if we complete this quarter circle to a circle, then we will get a circle that its radius is R and its center is also at point A. So we have two circles with the same radii and the same center. Okay, we have two circles with the same radii that is R and the same center that is A. Two circles with the same radii and the same center. They are not two circles, but one circle. It is the same circle. Therefore, the circle that will be created by completing this quarter circle to a circle is the same circle that blocks triangle HGE. Again, the circle that will be created by completing this quarter circle to a circle is the same circle that blocks this triangle HGE. And therefore, the circle that will be created by completing this quarter circle to a circle must pass through its three vertices of triangle G, and especially it must pass from point H. It is already passes from point G and E because the quarter circle passes from point G and E, and when we complete the quarter circle to a circle, it must pass from point H. Why? Because it also blocks triangle G. Again, the circle that will be created by completing this quarter circle to a circle must pass from point H because it blocks triangle G. Okay? So what is the definition? So I completed this quarter circle to a circle, and you can see here that the circle that we get here also blocks triangle HGE. Why? Because it passes through its three vertices H, G, and E. So what is the definition of line segment HE? Because of the fact that line segment HAE equals to this angle AE equals to 180 degrees in its size, any angle that's equal to 180 degrees in its size is defined as a straight line. Therefore, HAE is a straight line. But HAE is a straight line that touches the circle at 2 points H and E. Any straight line that touches the circle at 2 points is defined as a chord. So HAE is a chord. Again, HAE is a chord because it touches the circle at 2 points, H and E. But HAE is a chord that passes through the center of the circle, that is also from point A. And you know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, HAE is the diameter of the circle. If HAE is the diameter of the circle, HE is also the diameter of the circle. If HE is the diameter of the circle, you arrive to the conclusion that HE is the diameter of the circle. And we have, this is peripheral angle HGE, peripheral angle HGE. It is subtended on HE, that is the diameter of the circle. And we know that any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. So this peripheral angle HGE equals to 90 degrees in its size. And then we focus on the green quadrilateral ADGE. This is green quadrilateral ADGE. We have here those two opposite angles. Each opposite angle equals to 90 degrees in its sides, and the sum of two opposite angles, the sum of two right angles is of course equals to 90 degrees in the sizes. And we know that any quadrilateral that the sum of its two opposite angles is equal to 180 degrees, it is a cyclic quadrilateral. Therefore, the green quadrilateral ADGE is a cyclic quadrilateral. That is to say, we can block this quadrilateral by a circle. We actually blocked this green quadrilateral ADGE by this red circle, and then we implemented here rule 12. I'll print quickly on rule 12. According to rule 12 is true in any circle. So in any circle, if we have this circle could be any circle, and if we have in this circle chord BA, and the extended chord BA touches the current standpoint point P. We have here chord DC, and the extended chord DC also touches the same current standpoint point P. Then in this moment the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. You can definitely implement rule 12 in the red circle. Why? Because in the red circle we have chord GD, and the extended chord GD touches the current standpoint point H. Likewise, we have here chord EA, and the extended chord EA touches the same current standpoint point H. So all the requirements of rule 12 are satisfied, and therefore we can implement rule 12. According to rule 12, the following equation will be true: that edge D times edge G equals to edge A times edge E. Again, edge D times edge G equals to edge A times edge E. Repeat again. According to rule 12, if you focus on the red circle, the following equation will be true: that edge D times edge G equals to edge A times edge E. Edge D is 12, edge G in total equals to 12 plus X. Here, edge D is 12, edge G is 12 plus X, and it equals to edge A. Edge A is R, and edge E is the diameter of the circle, that is 2R. Again, edge A is R, and edge E is 2R. So in conclusion, according to equation 1, we found out that 12 times 12 plus X equals to R times 2R. Here, we will divide this equation 1 by 2, and finally we get that 12 over 2 is 6. So in total this expression equals to 6 times 12 plus X, and it is equals to, here R times 2R is 2R squared, and 2R squared over 2 is R squared. So actually according to equation 1, we found out that 6 times 12 plus X equals to R squared. Here we divided this equation 1 by 6, and finally found out that 12 plus X equals to R squared over 6. Here we subtract 12 from this equation 1, and finally found out that X equals to R squared over 6 minus 12. Okay, according to equation 1, X equals to R squared over 6 minus 12. Then I copied, we defined one side of square ABCD as y, therefore all of its four sides are equal to y, and then I copied this right triangle AD in any page, and we implemented the Pythagoras theorem of this right triangle ADE. So this is the right triangle ADE that I copied from the original domain. AD is one side of square ABCD, that is y according to the definition. What is the definition of AE? AE is the radius of the quarter circle, because point A is the center of the quarter circle, and point E is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, A is the radius of the quarter circle, that is equal to R according to our definition. Here A equals to R, and D equals to 12 units in itself according to what is given as the question. So in the right triangle AD, according to the Pythagoras theorem, DE squared equals to AD squared plus AE squared. So DE is 12, therefore DE squared is 12 squared, that is 144, and it is equals to AD squared. AD is y, therefore AD squared is y squared. plus AE squared. AE is R, therefore AE squared is R squared. So in conclusion, actually found out that according to equation 2, 144 equals to Y squared plus R squared. This is according to equation 2, while according to equation 1, we found out that x equals to R squared over 6 minus 12. In the next step, we join points A and C together by a straight line. Here we join points A and C together by a straight line. By joining points A and C, we created the right triangle, triangle ABC. So I copied this right triangle, triangle ABC in a new page, and we implemented the Pythagoras theorem on this right triangle, triangle ABC. What is the definition of line segment AC? Line segment AC starts from the center of the circle, that is to say from point A, and ends at point C, that is, and ends at point C, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of the circle that is equal to R according to our definition. So this is the right triangle ABC that I copied from the earlier drawing. In this right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. Again, AC squared equals to AB squared plus BC squared. AC is R, therefore AC squared is R squared, and it equals to AB squared. AB is Y, therefore AB squared is Y squared. Plus BC squared. BC is also Y, therefore BC squared is Y squared. So according to equation 3, we actually found out that R squared equals to Y squared plus Y squared, that is 2Y squared. So R, according to equation 3, R squared equals to 2Y squared. This is according to equation 3, while according to equation 2, we already found out that Y squared plus R squared equals to 144. Here we divided this equation 3 by 2, so R squared equals to 2Y squared. After we divide it by 2, we get that Y squared equals to R squared over 2, according to equation 3. While according to equation 2, we actually found out that Y squared plus R squared equals to 144. Now we can substitute Y squared in this equation 2 by R squared over 2 from this equation 3. We did it when we got that according to equation 2, Y squared is R squared over 2, according to equation 3, plus R squared equals to 144. Here we multiplied R squared by 2 and then we divided by 2 in order to have a common factor with R squared over 2. And finally in the numerator we will have here R squared plus 2R squared, because we multiplied R squared by 2 divided by 2, and it is equals to 144. R squared plus R squared plus 2R squared is 3R squared, so 3R squared over 2 equals to 144. Here we multiply this equation 2 by 2, and finally found out that 3R squared equals to 144 times 2 is 288. So according to equation 2, 3R squared equals to 288. Here we divided this equation 2 by 3, and finally found out that R squared equals to 288 over 3. 288 over 3 is 96. So according to equation 2, we actually found out that R squared equals to 96. This is according to equation 2. But according to equation 1, we already found out that x equals to R squared over 6 minus 12. Now we can substitute R squared in this equation 1 by 96 from equation 2. We did it, and we actually found out that x equals to R squared is 96. So in total this expression R squared over 6 will be equal to 96 over 6 minus 12. 96 over 6 is 12, and 96 over 6 is 16, and 16 minus 12 is 4. So actually found out that x equals to, for x, that is the length of this line segment GED, is equals to 4 units in its length. In the next step, I presented to you how to find out the length of this line segment GED that is equal to x according to the second method. So, in the second method, first of all, we know that all the angles inside square ABCD are right angles, so those 4 angles are all right angles. And we know that in any square, the opposite sides of a square are parallel to each other. So in square ABCD, it means that side DC is parallel to the opposite side AB. Again, in square ABCD, side DC is parallel to the opposite side AB. Here DC is parallel to AB. But AB is part of the straight line AE. Again, AB is part of the straight line AE. And we know that AB is parallel to to DC. So if part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. So the straight line AE itself must be also parallel to DC. So AE is parallel to DC. We know that AE is parallel to DC, and those two angles are defined as alternating angles, and they are located between the two parallel lines DC and AB, and therefore they must be equal to each other. Again, those two angles are defined as alternating angles, and we have the rule that alternating angles that are located between parallel lines are equal to each other. Those two alternating angles are located between the parallel lines DC and AE, and therefore they are equal to each other. So those two angles must be equal to each other, but this angle equals to theta, therefore this angle must be also equal to theta, because those two angles are equal to each other. In the next step, we did the construction, that is to say, from point G, we draw perpendicular on AB. Again, from point G, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as M. Likewise, we define the intersection point of the perpendicular GN and DC as M. By doing this construction, we created quadrangle DMAN. Inside quadrangle DMAN, we have 1, 2, 3 right angles, and therefore the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So inside quadrangle DMAN, we have 4 right angles. Any quadrangle that has 4 right angles must be a test rectangle plus a square. So we relate to this quadrangle DMAN as 4, that has 4 right angles as a rectangle. So quadrangle DMAN is a rectangle. And then we know that GN is perpendicular. GN is a perpendicular, it is absolutely a straight line. So if you focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is equal to 90 degrees, plus this missing angle. So in total, those two angles, they must be equal to 180 degrees, according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles of the left side of GN at point M to 180 degrees, this missing angle must be equal to 90 degrees in its size. So, therefore, triangle GMD is a right angle. So, copy this right angle GMD in a new page and analyze this right angle triangle GMD. So, actually, this is the right angle GMD that I copied from the original drawing. This is angle theta, GD equals to x, x is the variable that we are looking for. This angle equals to 90 degrees according to the rule that I mentioned. So in this right angle GMD, it is very easy to see that cosine theta equals to dm over dd. Again, cosine theta equals to dm over gd. So cosine theta equals to dm, and dm is the missing side, so we leave it as it is, over gd. Gd is x, so substitute gd by x. So in conclusion, we found out that according to equation 1, cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally found out that dm equals to x times cosine theta. Again, dm equals to x times cosine theta, according to equation 1. In the next step, I copy this right angle AD in a new page and we analyze this right angle triangle AD. But before that, we defined one side of square ABCD as y, and therefore all of its 4 sides must be equal to y. And especially side AD must be equal to y. What is the definition of a line segment AE? Line segment AE starts from the center of the quarter circle, that is to say from point A, and that's at point D, that is the point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AE is the radius of the quarter circle, that's equal to r according to our definition. Here, AE equals to r, and D equals to 12 units in its length according to what is given as the question. So, in this right angle ADE, it is very easy to see that cosine theta equals to AE over DE. Again, cosine theta equals to AE over DE. AE is r, DE is 12, so in total cosine theta equals to r over 12 according to equation 2. But according to equation 1, we already found out that dm equals to x times cosine theta. So now we can substitute cosine theta in this equation 1, by r over 12 from equation 2. We did it and finally found out that dm equals to x and times cosine theta. And cosine theta is r over 12. Therefore, in total, dm equals to xr over 12. Here, dm equals to xr over 12. This is side dm. This is equal to xr over 12. And we know that DMAN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMAN, side DM equals to the opposite side AN. But DM equals to XR over 12, therefore AN must be also equal to XR over 12. Likewise, according to the same rule in the same rectangle DMAN, side AD equals to side NM. But AD equals to Y, therefore NM must be also equal to Y. In the next step, I copy the right triangle DGM in the new page and we continue to analyze it. So this is the right triangle DGM that I copied from the original drawing again and we continue to analyze it. In this right triangle DGM, it is very easy to see that sinus theta equals to GM over DG. So sinus theta equals to GM, GM is the missing side, so we leave it as it is, over DG. DG is X, so substitute GD by X. So in conclusion, we found out that sinus theta equals to gm over x according to this equation, equation 1. We multiplied this equation 1 by x and finally found out that gm equals to x times sinus theta. Again, according to equation 1, gm equals to x times sinus theta. Then I copied the right triangle ADE in the new page and we continue to analyze this right triangle ADE. Side AD equals to y, A is the radius of the circle that is equal to y, and D equals to 12 units according to what is given as the question. So in the right triangle ADE, sinus theta equals to AD over DE. So sinus theta equals to AD, that is y, over DE, that is 12. So in total, according to equation 2, we actually found out that sinus theta equals to y over 12 according to equation 2. Well, according to equation 1, we have already found out that gm equals to x times sinus theta. So now we can substitute sinus theta in this equation, equation 1, by y over 12 from equation 2. We did it and we finally found out that gm equals to xy over 12. Okay, gm equals to xy over 12. So here, this is side gm. This equals to xy over 12. Then I joined points A and G together by straight line. So what is the definition of line segment AG? Line segment AG starts from the center of the quarter circle, that is to say from point A, and ends at point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle that is equal to R. So I copy the right triangle AGN in the new page and we implemented the Pythagoras theorem on this right triangle AGN. We just right now found out that AG equals to R, the opposite AG equals to R, AN equals to X over 12, and what is the length of GN? GN equals to GM plus MN. So GN equals to GM, that is XY over 12 plus Y. So in total, GN equals to XY over 12 plus Y. So put again, this is right triangle AGN, this is a copy from the original domain. I put again that GN equals to xy over 12 plus y, an equals to xr over 12, and the opposite ag equals to r. According to the Pythagoras theorem, in this right triangle AGN, ag square equals to an square plus ng square. So ag equals to r, therefore ag square is r square, and it is equals to an square. An is xr over 12, therefore an square is xr over 12 square. Xr over 12 square equals to x square times r square over 12 square, that is 144. Plus gn square. Gn is y plus xy over 12, therefore gn square is y plus xy over 12 square. Then we took y as a common factor from this expression and found out actually that according to equation 1, r square equals to x square times r square over 144. So here we took y as a common factor from this expression. So what is left from y after we took from it y as a common factor? What is left is actually 1. And what is left from xy over 12 after we took from it y as a common factor? What is left? It is actually x over 12, all squared. Then we opened one pair of brackets in this expression and found out actually that according to equation 1, r square equals to x square times r square over 144 plus y square. Here, repeat again, we opened one pair of brackets here. So after we open the one pair of brackets, we have here 1y squared and 1 plus x over 12 also squared. Okay, then we multiply 1 by 12 and then we divide it by 12. In order to have a common factor, we have x over 12. So in total, in the numerator, we have x plus 12 divided by 12 squared. Do it again. So expression will be equal to x plus 12 over 12 squared times y squared plus x squared times r squared over 144. That is equal to r squared according to equation 1. Then we have the algebraic identity that states that a over b squared equals to a squared over b squared. According to this algebraic identity, we get that 12 plus x over 12 squared will be equal to 12 plus x squared over 12 squared. Repeat again, 12 plus x over 12 squared, according to this algebraic identity, will be equal to 12 plus x squared over 12 squared, that is 144. Multiplied by y squared plus x squared times r squared over 144, that is equal to r squared according to equation 1. Then I copied the right triangle ABC in a new page and we implemented the Pythagoras theorem on this right triangle, triangle ABC. But first of all, we found out the length of the hypotenuse AC. What is the length of the hypotenuse AC? The hypotenuse AC starts from the center of the quarter circle, that is also from point A, and that's the point C, that is the point of the circle itself. Therefore, AC, this is exactly the definition of a radius. Therefore, AC is the radius of the quarter circle, that is equal to R. So AC equals to R. A, B, and BC are both the sides of square ABCD, that is equal to Y according to our definition. So in the right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. AC is R, therefore AC squared is R squared, and it is equal to Y squared to AB squared. AB is Y, therefore AB is Y squared plus BC squared. BC is also Y, therefore BC squared is Y squared. So in conclusion, according to equation 2, we actually found out that R squared equals to Y squared plus Y squared, that is 2Y squared. So according to equation 2, R squared equals to 2Y squared. This is while according to equation 1, r squared equals to x squared times r squared over 144 plus y squared times 12 plus x squared over 144. This is according to equation 1, while according to equation 2, we found out, actually, we already found out that r squared equals to 2y squared. So now we can substitute r squared in this equation 1 by 2y squared from equation 2. We did it and found out that according to equation 1, r squared is 2y squared, and this equals to x squared times r squared, and again r squared is 2y squared over 144 plus y squared times 12 plus x squared over 144. So here we divided this equation 1 by y squared, and we found out actually 2y squared over y squared is 2. Here y squared will get cancelled, we left only with 2x squared over 144. Here also y squared will get cancelled, and we left only with 12 plus x squared over 144. Here we multiply this equation 1 by 144, and finally found out that according to equation 1, 2 times 144 is 288. Here, after we multiply this expression by 144 in the denominator will get cancelled, we left only with 2x squared. Here, 144 also get cancelled in the denominator, we left only with 12 plus x squared. So in conclusion, according to equation 1, we actually found out that 288 equals to 2x squared plus 12 plus x squared. Here we open the brackets of this expression and found out actually that according to equation 1, 288 equals to 2x squared plus 144 plus x squared plus 24x. So 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144. Here we subtract 288 from this equation 1, and finally found out that in this side of the equation we have 3x squared plus 24x, and here we have 144 minus 288 equals to minus 144, and 288 minus 288 equals to 0. So in conclusion, according to equation 1, we found out actually that 3x squared plus 24x minus 144 equals to 0. Here we divided this equation 1 by 3, and finally found out that according to equation 1, 3x squared over 3 is x squared, 24x over 3 is 8x, and finally minus 144 over 3 is minus 48, and it is equal to 0. So x squared plus 8x squared plus 8x minus 48 equals to 0. It is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 40x equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So now we have to put the values of a, b, and c, those values that we found for our specific quadratic equation in this general formula for x, in order to find out the values of x for our specific quadratic equation. I remind you that x in our equation, in our specific quadratic equation, is defined as the length of line segment GD. So x is the length of this line segment GD. We have to find out the length of this line segment GD. So we put the values of a, b, c in this for our specific quadratic equation in this general formula for x, and we found out the values of x. So we did it, and we found out actually that x equals to minus b. B is 8, therefore minus b is minus 8, plus minus square root of b squared. B is 8, therefore b squared is 8 squared, that is 64, minus 4 times a is 1, so minus 4 times 1 is minus 4, times c. C is minus 48, so minus 4 times minus 48 is plus 192 divided by 2a. A is 1, therefore 2a is 2 times 1, that is 2. So in conclusion, we found out that x equals to minus 8 plus minus square root of 64 plus 192 over 2. So x equals to minus 8 plus minus, and 64 plus 192 is 256. So inside the root we left only 256 divided by 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 divided by 2. So here we have two solutions that are possible for x. The first solution is x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution, x equals to minus 12. But x can never be equal to minus 12, because x is the length of this line segment GD, and x is the length, it must be a positive number, it can never be equal to a negative number. So we cancel the negative solution, and we took into account only the positive solution for x. And the positive solution for x is x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So we actually found out that the length of this line segment GD that is equal to x is equal to 4 units in both methods. Okay? Thank you very much.